6 inequalities in one triangle. These are long notes. I'm definitely going to want to pause them and make sure you're getting everything down. Maybe rewatch parts of it. It is they're long and a little bit complex. Remember, I will answer any questions you have when I get back. We'll have several days of review before our test on the unit. Okay, 5-6 inequalities in one triangle. So we're going to talk about exterior angles and inequality theorem. And an exterior angle inequality theorem says that an exterior angle of a triangle must be greater than each of its remote interior angles. So first off, what we're saying here is, before we get to this part, let's talk about exterior. That's going to be the outside of the triangle. Interior angle is inside the triangle. Remember that a triangle has a total degrees, 180 degrees, of the sum of all of its interior angles. Any exterior angle is always going to be greater than each of its remote interior angles. So remote means not touching. So remote means it's not adjacent to. So that would be remote or not adjacent. So 4 is adjacent to this angle that's not named here. The remote angles, so angle 1 and angle 2, are remote to angle 4. So we know that angle 4 must be greater than angle 1 and angle 2, or angle 1 or angle 2. So this degrees has to be greater than the degrees measure for angle number 1 or the degree measure for angle number 2. So in this case, angle 4 is greater than angle 1 and angle 2. So let's look at some ways that we can apply that new theorem. We're going to explain why the measure of angle 1 is greater than the measure of angle 2. So why is angle 1 greater than angle 2? Well, angle 1 is outside the triangle. That makes it an exterior angle. Angle 2 is a non-adjacent interior angle. So this angle would be adjacent. These two are remote, not touching or sharing a side with this angle. So we know that angle 2 is less than angle 1 because the exterior angle inequality theorem says that the exterior angles are always greater than the remote interior angles. So angle 1 must be greater than angle 2 because angle 2 is an interior remote angle, and angle 1 is an exterior angle. So let's put angle 2 is an interior remote angle, and angle 1 is an exterior angle. So based on the exterior angle inequality theorem, now we know that angle 1 is greater than angle 2. And this one, why is angle 1 greater than angle 2? Well, angle 1 is an exterior angle from this triangle. Angle 2 is also an exterior angle, but we have to pull in some of this stuff that we know from other lessons, from our base knowledge or fundamentals we've been learning. So angle 3 and angle 2 are formed by crossing lines. That means angle 2 and angle 3 congruent, because they are vertical angles. So angle 1 has to be greater than angle 2 because angle 3 and angle 2 are congruent, and angle 3 is a remote interior angle. So angle 1 must be greater than angle 2 because angle 2 is congruent to angle 3, remember, because they're vertical angles, and angle 3 is an interior remote angle. And so because of the exterior angle inequality theorem, then angle 1 has to be greater than angle 2. So angle 1 must be greater than angle 2 because angle 2 is congruent to angle 3. And angle 3 is an interior remote angle, while angle 1 is an exterior angle. So now we know that angle 1, the measure of angle 1 is greater than the measure of angle 2. So we're using angle 3 because it's congruent to angle 2, but the question asks us to compare the measure of angle 1 and the measure of angle 2. And we really should be using the measure of angles here. I'll do a better job of that later on. Alright, so another theorem is the angle-side relationships in triangles theorem. If one side of a triangle is longer than another side of the triangle, then the angle opposite, the longer side, will be greater than the angle opposite the shorter side. So we're saying because side AB is longer than side AC, now we know that angle C has a greater measure than angle B. That is that angle B is across from the shorter side, angle C is across from the longer side. So now we know that the measure of angle B has to be greater, the measure of angle C has to be greater than the measure of angle B. So we are going to use the measures there. So that's going to be the measure of angle C is greater than the measure of angle B. All these symbols are getting kind of confusing, but the measure of angle C has to be greater than the measure of angle B. So this is a converse. This is a converse to the angle-side relationship in triangles. This is the, it's the same thing, but it's the converse. So if the angle of one triangle is greater than another angle of the triangle, so if an angle is greater than another angle, then the side opposite the greater angle will be longer than the side opposite the lesser angle. So 35 is a smaller number than 50. So that means that the side across from the angle that measures 35 is going to be shorter than the side across from the angle that measures 50. So we're comparing the side lengths AB to the side length of AC based on the measure of the angles. Since the measure of the angle across from AB is greater than the measure of angle across from AC, now we know that AB is longer than AC. And you can use a segment if you want. You don't have to, remember. Or you can pause this at any point to catch up. I'm going through because I don't have anybody here asking questions or anything, but you can pause it and catch up. Example 3, list the angles of a triangle ABC in order from least to greatest. So, looking for the shortest side. So 12, 9, and 14 are the measures, so 9 is the shortest side. So now I know that B is the smallest angle. Since it said least to greatest, we're going to say angle B. Then we're going to say, well, 12 is the next smallest. So the angle across from that side is angle C. And the side across from the longest side, that's angle A. Angle A is the largest angle. Okay? List the sides of the triangle in order from least to greatest. So now they gave us two angles, and they want us to tell them which side is shortest, which side is the middle, and which side is the longest. And they want us to go from least to greatest. So I'm looking for the side across from the smallest angle, but I don't have a measure for this angle. I have to remember 180 degrees in a triangle. If I'm missing an angle, 70 plus 60 is 130. So 180 minus 130 is 50. Now I know that angle B measures 50. So 50 is the smallest angle. So the side across from 50 is going to be the shortest side. 60 is the next smallest angle. So the side across from 60, that's AB, is going to be the middle length side. And the side across from the largest angle, that's going to be BC. That is the longest side. I already did that. So it's going to be the smallest, the shortest is AC. Then the next is AB, and then the longest is BC. All right, so this one is a little bit tricky. I'm going to take some of this stuff out. All right. It says determine which side is the shortest in the diagram. So this one's a little bit tricky because they're sharing a side. But there's a trick. I don't know how else to tell you this except for the trick. So the first thing we're going to do, we're looking for the shortest side, the first thing we're going to do is, we don't have the measure of this angle and this angle, so we're going to find the measure of those angles. So if I add 48 and 47 and subtract them from 180, that would give me that other angle. So 48 plus 47 equals 95. 180 minus 95 is 85. I'm going to do the same thing here. 95 plus 40. I think that's 135. I'm going to subtract that from 180. And now we know that that angle, not angle B, because there's two angles there, but angle DBC measures 45. Now what we're going to do, so that's how we got the measure of those angles. We have to do that first. If there's missing angles, we have to fill that in first. So how can we do it if we don't know the side length? So we're going to use this trick. So there's a trick here, all right? The trick is we are going to randomly assign side lengths. We don't know how long they are, but I'm going to pick one triangle, and I'm going to start in this bigger triangle. It doesn't matter, though. You can start at whichever one. We're going to assign kind of random side lengths. So I know in this triangle, here, the longest side is across from this angle. So that's the longest side. So BC has to be the longest side in this triangle. So I'm going to give it a length of 15. BC is not 15 any units long, all right? We just know we have to have some measures to compare, especially since they're sharing. The only way to do it when they're sharing one side with another triangle is to assign it a random length. So 95 is the biggest angle, so BC has to be the longest side. So now we're going to go to the next biggest angle, which is 45. And the side across from that has to be smaller than 95. So I've got to go, it can't be 15, BC can't be 15, so I'm going to assign that a length of 14. And then the smallest angle in this triangle I've highlighted in green, triangle DBC, is 40. That's the smallest angle, so now I know that this DB has to be the shortest side. So I'm going to give that a measure of 13. That's smaller than both the other sides because it's across from the smallest angle. Now in this triangle, if if DB is 13 in this triangle, we're going to have to say that DB is 13 in this triangle as well. They share the side, whatever length that is, it's the same in both triangles. We don't know what length it is, but that would be, it has to be the same. Okay, so since I assigned DB 13 in the green triangle, now in this other adjacent triangle, we're gonna start with the side that's across from 13. The side that's across from 13 is the middle, is across from the middle angle, right? So 48 is bigger than 47, but smaller than 85. So the side across from 48 is the middle number. So what I'm gonna do now is I know the side across from 47 has to be smaller than 13 because 47 is smaller than 48, so the side across from it's got to be smaller. So we're going to call that side 12. Now we have one angle left and one side left that we have not assigned a random length, and it's kind of random, kind of not. We start with a random number and then everything is compared, or side length, everything is compared to that. So we have one angle left. So angle ADB in this other triangle, it measures 85. That's the largest angle in this triangle. So now we know that AB has to be the longest side. So if this is 12, that's the small side across from the smallest angle. The side across from the middle angle is 13. Now we know that the side across from AB has to be bigger than 13. So we're going to say that's 14. So if we're looking for the side that's shortest, it's going to be side AD. Alright, so here's the trick in words. In one triangle, assign random side lengths based on the measure of the angles. So here we had to start with one random number. I would always use 15. Always start with 15. You don't have to technically, but I would always start with 15, 25, something like that. So 15 was what we started with, and then we put in side length 14 and side length 13 based on the smaller angles. Since they share a side, that side length has to be the same. Gosh dog it, I'm trying to get that square off. We use that to assign random lengths based on the measure of the angles in the other triangle. So we start in the middle in this other triangle, remember, because we assigned it 13 here because it was across from the smallest angle. Since they share this side, they have to be congruent. So if that one's 13, then we have to say it's 13 in the other triangle as well. So side AD is the shortest. Oh, let's do it over here. Side AD is the shortest. And by the way, BC would be the longest because it has the biggest number here. This was the answer for how we knew the answer of our question, AD. All right. I'm going to keep going. The two shortest sides of a triangle must be longer than the third side, and that is the sum of the two shorter sides. So for example, and they can't be equal, right? So there's only certain side lengths that will allow you to create a triangle. Not all. There are certain combinations of side lengths that will not connect, right? You could not make a triangle out of them. And the rule is the sum of the two shorter sides of a triangle must be longer than the third side. And remember, they cannot be equal. Not equal, but greater than. So let's look here. Is it possible to form a triangle with the given side length? Explain why. Well, the shortest, these are the two shortest, this is the longest. So we're going to add these together. I know that it's not because the two shortest sides, 6 plus 8, that equals 14. Well, 14 is not greater than 14. It's equal to. So these three side lengths will not create a triangle. 15, 16, and 30. Well, let's start here. (15) and 16, the shortest sides. If you add those together, those equal 31. The longest side is 30. 31 is greater than 31. So, yes, you can create a triangle with those side lengths. Let's look at this other example. Two shortest sides, 2 and 8. The longest side is 11, so we want to know if you add the two shortest sides, 2 plus 8 equals 10. 10 is not greater than 11, so you cannot create a triangle with side lengths of 2, 8, and 11. All right, and the final concept I think in today's notes is that if we're given two sides of a triangle, you can find the range of the third side. So there is a range of values. If you know two sides of a triangle, there's a range of values that the third side can fall within. If it doesn't fall within that range, so it can't be too short and it can't be too long. So we can find that range by adding and subtracting the two sides that you have and plugging them into the following inequality. So this is your formula you want to remember. Right, so if they give you, given two sides, we're going to subtract the two sides and add the two sides. And then we'll know the range of values that the third side could be, because there's not just one value that x could be. There's a whole range of possible values that it could be. So what we're going to do, you're always just going to do for the first subtract, you're going to subtract the biggest minus the smallest, because remember it's the length. So 5 minus 2, and we're going to say that's less than x, or literally this is the formula you're using here. Whatever two sides they give you, you subtract the biggest minus smallest. That's the subtract part. Then you write less than x, just like it is here. And now we're going to add the two sides together, and that is, it's going to be 5 plus 2. So 5 minus 2 is less than x, and x is less than 5 plus 2. So we're going to say that the range of values is from 3 to 7. Really, I don't remember if I rearranged that, but hold that thought for just a sec. Okay, so what does that mean? We have to know what that means. The other way to write this is a compound inequality. You learned about this in algebra. The other way to write that is x is greater than 3 and x is less than 7. So it's got to be any value that's more than 3 but less than 7. So which means that the third side can be any number greater than 3 and less than 7. Remember, you can pause to catch up. So if we want to find the range for the measure of the third side of a triangle, given the measures of two sides, we're going to use this formula. Subtract the two numbers, biggest minus smallest, and add the two numbers and plug it into this compound inequality. So the third side, this is the range of the third side, so that's what we're finding right here. We're finding the range of the third side. What is the shortest it could be and what is the longest it could be? And this is how we find it. So we're going to subtract 7 minus 3. Okay, I don't know if I did that or not, so let's just do it here. So the third side, we're going to go ahead and plug in here. So it's going to be 7 minus 3 is less than x, which is less than, add 7 plus 3. So we're saying that 4 is less than x, which is less than 10. That's how you write that as a range. But remember what that means. That means that x, or the length of the third side, has to be greater than 4, and it has to be less than 10. So any numbers, not 4 and not 10, but any number in that range, the third would work to make a triangle with these two sides. So 3, 7, and 6 would make a triangle with, could make a triangle. 3, 7, and 4 could not make a triangle, right? So that would be an example of a value that would work and a value that wouldn't work, given that this is the range of values for that side. All right, example 10. If we had two sides of a triangle, 60 kilometers and 93 kilometers. We're going to use this formula. We're going to subtract them and plug in, and then add them and plug them into this formula. So 93 minus 60, which is less than x, has to be less than 60 plus 93. So I think that's 33 is less than x is less than 153. So the third side, so let's put over here, the third side can be anywhere in this range. The third side in this triangle can be, x can be greater than 33, and has to be, x has to be less than 153, where x is the length of the third side. Alright, so x is the length of the third side. Alright, last but not least, we're subtracting 19.4 and 7.2, plugging it into our formula. So 19.4 minus 7.2 is 12.12, sorry, 12.2, which is less than x, which is less than 16 point, oh no, that's 19, so it's 26.6. Yeah, which is less than 26.6. So that's the third side for the first example. So for the last example, the third side, so x is going to be greater than 12.2, and it has to be less than 26.6. So if I'm picking a third side to create a triangle with a side measure of 17.2 and 19.4, I can pick a side measure of 20 because it falls in this range. But I can't pick a side measure of 10 because the third side has to be within that range. Alright guys, that's it. Remember, pause if you need to, go back if you need to. Take care, see you soon.